How's it, grade 10s? Today we're going on to converting fractions to decimals. So if we just have a look at the notes here, what you can do with the videos, you can just pause at any time, just write down the notes into your workbook. Okay. So converting fractions to decimals. All fractions can be written as decimals. Some fractions can be converted into decimals by writing them as equivalent fractions with denominators of 10, 100, 1000. Okay, so don't worry about this too much. I'll go through the examples just now and explain it. Okay, the number of decimal places is the same as the number of zeros in the denominator. This method of conversion will always result in a terminating decimal. Okay, so if you divide anything by multiples of 10 like this, 10, 100, 1000, 10,000, 100,000, etc., it will always terminate. Okay, so if we have a look at these examples here, convert the following fractions into decimals. So what I'm going to do first of all is I'm going to try and make my life a little easier. And I look at these denominators and I ask, can I get them to multiples of 10? So for example, can we get 25 to like 10, 100, 1,000, 10,000, and so on? So we can see we can get that one to 100, okay, by multiplying by 4. 2,000, we can definitely get that to 10,000 by multiplying by 5. This 300, on the other hand, we can't get it to any multiple of 10 by multiplying, but what I can do is divide by 3, and that will give me 100, and then that will help us. So if we go through these examples, so the first one, we've got 2 over 25. So what I do here is I just multiply this bottom one by 4, and that will give me 100. Okay, but what I do to the bottom, I must do to the top. So I must also multiply the top by 4, and we get 8. Once we got it like this, then the number of zeros, we can just move the decimal. Okay, so if the decimal is over there and we've got 2 zeros, it'll be 1, 2. So we've got 0,08. All right, and it's as easy as that. If we go to the next one, we've got 44 over 2000. Okay, now I know I can get that to 10,000 by multiplying by 5. Okay, so that denominator will now become 10,000. But what I do to the bottom, I must do to the top. So I must multiply the top by 5. So 44 times 5 is going to give us 220. Okay, so we've got 1, 2, 3, 4 zeros. So I must move the comma 4 places. 1, 2, 3, 4. So that's going to give us 0,022. Okay, I don't need to put that last zero in because it won't count. Okay, so if we look at example C, minus 354 over 300. Now, like I said earlier, multiplying by anything is not going to really get us to any multiple of 10. But what I can do is I can divide that by 3. Okay, and 300 divided by 3 will give us 100. Now, up at the top, we need to multiply this by 3 as well. Okay, so 354 divided by 3 is 118. Move the decimal 2 places because we have 2 zeros. So 1, 2, and we get minus 1,18. All right. So always try and get your denominators to multiples of 10. It's going to make your life so much easier. All right. Moving on. Now, converting fractions to decimals where we can't write the denominator as multiples of 10. In other words, 10, 100, 1,000, okay? The numerator must be divided by the denominator. So what I'm going to do is I'm going to go like the old school way that you guys learned in primary school, and I'll show you with examples in a second. This method of conversion will always result in a recurring decimal. The number of decimals that repeat in a recurring decimal is called the period of the decimal. So if you've got one digit that's repeating, then it is just 1. The period is 1. If you've got 2 digits, the period is 2, and so on. Okay, so let's have a look at some examples here. All right, so this is example 2. Question A, 12 divided by 7. So like I said, grade 10, so what I'm going to do here is I'm going to do it the old-fashioned ways, where we do the division like this. And I'm just going to put 3 decimal places in there. Okay, so first of all we say, does 7 go into 1? No, so we put a dot. Does 7 go into 12? Yes, it does. It goes once. Remainder 5. Okay, and I just carry that decimal place over there. 7 into 50, yes it does, it goes 7 times, remainder 1. 7 into 10, once, remainder 3. 7 into 30, 4. Okay, and what I'm going to do is I'm just going to leave it like that at 3 decimal places. Okay, because the reason why I had to go this route is we can't get 7 as a multiple of 10. Okay, there's no ways we can get it to 10, 100, 1,000, and so on. Okay, if we look at example B, 7 over 13. Okay, again I must go this route because we can't get 13 to be 10, 100, 1,000, and so on. Okay, so the old-fashioned way, where we put 7 here, I'm just going to go to 3 decimals, 1, 2, 3, and the 13 goes outside here. Okay, does 13 go into 7? No, it does not. Put down the 0, carry the comma. 13 into 70, yes it does. 5 times, remainder 5. 13 into 50, 3 times, remainder 11. 13 into 110 goes 8 times. And I'm not going to bother going any further than 3 decimals. Okay. Example C, minus 1 over 12. Okay, so I'm going to put the minus 12 outside. And we've got 1 here. And I'm just going to go to 4 decimal places with this one. And you'll see in a second why. Okay, so whatever my answer is going to be here, it's going to be a negative because we have this negative divided by positive. So I know the final answer will be negative. Okay, so 12 into 1, it doesn't go. Carry the 0. 12 into 10 does not go. Put down the 0. 12 into 100, yes it does. It goes 8 times. And then we have remainder 4. 12 into 40, 3 times, remainder 4. 12 into 40, 3 times, remainder 4. So we'll have 40, then it'll go 3 times, remainder 4, and so on and so on. So you can see that this one is going to start repeating from there. So the period of this one would be 1. Okay, and that's your final answer. So grade 10s, what I would like you to try on your own is I want you to try this 1 over 19. I will post up the solution tomorrow, but I want you guys to give that one try on your own. And then for homework, you've got exercise 1.1, number 6. Thank you.